All right, I think we're going. So I'm not going to show my face. I've literally tried to take this like 4 times with my face in it, and it doesn't work. So I'm sorry about that. JD, I'm sorry I'm sending this to you so late. My life has become completely chaotic. A bunch of my slides got deleted. I know it sounds like excuses, but anyways, I apologize. Forgive me. I'm sorry. Anyways, let's just get into it. So my article was by KJ Willis and HBJ Birks, titled "What is Natural? The Need for a Long-Term Perspective in Biodiversity Conservation." All right, let's go right ahead. So the main point of the article is to show that paleoecological history can be very beneficial to conservation of various species. I also apologize for the lack of pictures that some slides might have. Essentially, just how we can use this history for conservation. I'm gonna get obviously into that. That's the main point. I'm sorry. So background. So what is paleoecology? Paleoecology is the interaction of organisms with each other and the environment through a geologic timeline. So this is kind of understanding why it's so important in history, because now we're getting we can go really far back and kind of understand what organisms were where and things like that. So it's also important because as time goes on and our technology evolves, the resolution of the data is becoming more spatial, meaning we're getting more information and a better understanding. We're going to get more details and things like that. So it's going to start to become more clear as we, as humans, kind of progress. Some more background. So ecosystem change as a response to events like ecosystems change as a response to events like climate change, wildfires, and invasions. So specifically, biological invasions, like the introduction of a non-native species. It could also be an invasive species. Then there's climate change, like changing parts of an ecosystem, such as temperature or soil. Obviously, that would have a big impact on the ecosystem. And wildfires will have a big impact on the ecosystem based on their frequencies or their severities, or if they were used as a farming technique or things like that. So there's a lot of different possibilities there. So let's get into the summary. Biological invasions. So some biological invasions, the article talks about how they can be responsible for community changes and even extinction. So let's say you bring in, let's say plant A is the native species to this area, and at a certain time, plant B is introduced by humans, and plant B completely outcompetes plant A. Even though plant A is the native species, plant B is going to be kind of in control of this environment and could cause an extinction or the ecosystem to change. And then the article also discusses how it can become unclear between what is native and what is not. As I said before, if a really long time ago, two plants, a plant was introduced to a different area, and it's overrunning another plant, it becomes difficult to tell which plant, without or paleoecological history, which plant is the native species. And when you're talking about conservation, you look to conserve the native species, not the non-native species. So these types of things could affect whether or not a species is being protected in its origination area. Getting into wildfires, the article talks about how important wildfires are to shaping function of fire-prone communities, and also discusses management plans are put in place to control human-induced fires. Now, this I found really interesting because it's assumed that human-induced fires cause a change in the ecosystem structure. But a lot of times these things are deduced with no paleoecological evidence. And so, a plan is put into place and it's kind of there just because people are assuming that that's what needs to be done. And it's not necessarily always the right thing to be done. So continuing with the summary, we've got climate variability. So the article discusses how conservationists have developed, conservation organizations specifically have developed strategies to conserve biodiversity in a changing climate. So the two questions that they asked in the article were, where will biota move in response to climate change, and which species and regions will be most at risk? This is important because it can affect, like, if there's a plan put in place to protect or whatever that they're gonna do. I'm sorry, guys. I'm going on. This is bad. I'm just gonna move on. Sorry. Using paleoecological studies, researchers are able to take present day species and run models using historical data to predict outcomes of climate change. So the article had a really good example of this. How it did. It was called like a. It was basically a reverse model. So they started from later, further back in time, and went forward to the present, and they used. They would use a model of a different species that had similarities to a present day species and run the model to kind of find errors in predictions and stuff like that. So thresholds within natural variability. So the article talked about how, you know, variability throughout time it's inherent and it's inevitable. You know, you can't escape variability. Some really good examples that it gave were billabongs, which are basically like these kind of lakes that are formed. These lakes or ponds that are formed as a river starts to decline in water level, and it's basically the water that is left over there. So billabongs in Murray River in Australia do not support microphyte beds anymore, but they used to, according to the paleoecological data before Europeans arrived. So that's one variability, and then another one that another example the article provided was the paleoecological studies in the Colorado Delta ecosystem. Point out that the decline of 94% of shelly benthic macroinvertebrates due to human damming and irrigation projects. So kind of another example of just humans came to this area and, you know, things changed based on other events, cause and effect, essentially. So what the authors concluded, the author's primary conclusions were that we need to have conservation biologists and paleoecologists work more closely together. I'm gonna get a little bit more into that when we get to the critique discussion. Paleoecologists can bring a historical perspective to our present issues. That was, in my opinion, the biggest takeaway of the conclusion. Was that we need to start using a lot more, especially now that the resolution of our data is getting so much, you know, more clear. We need to start using our historical data a lot more so that we can use this to help the present and predict the future. And then I kind of just said, you know, the increase in amounts of paleoecological data is allowing for a more temporal resolution. You know, yeah. So the conclusion continued. Their conclusion did a really good job of the challenges. There was 4 specific challenges and needs that needed to be met before we could see some real change. So we needed more paleoecological studies in biodiversity hotspots. So basically, we need to do more studies in these areas where there's a lot of different species, because at the moment there just isn't a lot of research. We need to improve taxonomic resolution of... I had a typo there, I apologize. We need to improve our taxonomic resolution. Addressing terrestrial paleoecological data, looking at an ecosystem's health to determine its health history. So basically, just going back and looking at our data to determine how healthy an ecosystem was and kind of compare it, or at least not necessarily compare it, but be able to, compare it to the present and then hopefully be able to predict how the ecosystem will act in the future based on different actions. And we just need to have, like I said, further discussion and collaboration of paleoecologists and conservation biologists. This was a really important thing that I took away from this, was because the more history we bring into our conservation efforts, the more we're going to be able to act in the present. And I thought that was important just because our generation is the generation doing that. That's kind of just an extra thing for you guys. So critical discussion. Also, sorry, still no pictures. I'm bad at the pictures. There was a great. It was honestly really hard for me to critique this article because I felt like it was exactly how I would have written it. I know that's kind of a bad excuse, but I literally was like having trouble doing this. Breaking down the main points. So there was 4 major sections. We had climate variability, wildfires, biodiversity invasion, and then the threshold variability. And then we also had our introduction and our conclusion, and I really liked the structure of it. I thought it was well done. The only issue I had was with figure 1 in the biodiversity invasion section. Like, it was just some pictures that didn't really come up until the last section, and there was some really great data points in that section that I would have liked to see in a graph. So the data, all of the graphs were great except for, in my opinion, figure 4, just because it was kind of confusing to like look at, and it was placed really oddly. And then the conclusion, I really liked all of the challenges that were met that they wanted to meet, but I didn't feel like they gave a lot of what they took away from the research. It kind of just felt like a here's all of this research, and then here is what we should, like, what needs to happen. You know, it wasn't like this like they didn't really explain what they gathered much, in my opinion. But I don't know, I didn't explain that very well. But and yeah, that's my references. Well, that's it. I apologize for the crappy presentation, guys. Please understand I had some difficulties, and this week's been insane. So hope you enjoyed. Bye bye.